Hello, viewers and learners. Welcome to Fike Maths with Tirema. Uh, and today we're going to be looking at a very important topic in physics, Upthrust and Archimedes principle. Upthrust and Archimedes principle. So, as usual, before we dive in, what I have for you today is you may not be responsible for where you are today, but you are definitely responsible for where you'll be tomorrow, right? That's something noteworthy, all right? That's a very noteworthy point, all right? Because truly, some factors, some people might have been responsible for where you are today. Maybe you are a learner, you're watching me right now, or a student, you're watching me right now. You may not be satisfied with the with your current situation, the kind of maybe you are not performing as expected. You may not be satisfied with that, of course. But then some people, some factors might have been responsible for that. But what is going to determine, that's your present, that's your current situation right now. So if you're going to change that situation, if that situation is going to change, then you have to be responsible to change it because nothing changes until you change. So you're going to be responsible to change it so that it will change what tomorrow will bring. All right. So that's why I said you may not be responsible for today, but you are definitely responsible for tomorrow. You will not be responsible for where you are today, but you are responsible for where you will be tomorrow. So that means you start doing things that will change where you're going to be tomorrow. You start studying. If there is a need to participate in tutorials, you participate. You hear students saying, no, I didn't have a good physics teacher. I didn't have a good mathematics teacher when I was in SS1. So now in SS3, I've been affected. Yes, we've had all of that. Yes, but what are you going to do now? What are you going to do now? How are you going to change that situation so that where you're going to be tomorrow, it will be positive, it will be satisfactory. All right. So, having said all of that, let's dive into what we have today. So, we have upthrust and Archimedes principle. Now, what is upthrust? Upthrust is an upward force, right? Upthrust is an upward force that is acting on an object that is partially or fully immersed in a liquid. And of course, you know that liquid can be water, can be kerosene, can be petrol, can be any other liquid of related that's related to such. So when you fully or partially immerse an object into a liquid, it will experience an upthrust. That upthrust is called upward force, and that's what you can see illustrated here. This is the upthrust acting on this object that is immersed in liquid. This is the liquid, this is the object. Alright? So this is the weight of the object acting downward. An object that is partially or fully immersed in a fluid will experience an upward force. We experience an upthrust, which is the upward force acting on that object. All right. So that upthrust is equals to the weight of the liquid experienced or displaced by that object. The weight of the liquid displaced by that object. That would be the upthrust. All right, which I have explained earlier. Now, which means that when an object is immersed in a fluid, it's before it is immersed in a fluid, it has a particular weight, which is its actual weight. All right. So you call it weight in air. That is its actual weight. But as soon as it gets into the liquid, as soon as it is immersed in a liquid, it will reduce in weight. Why will it reduce in weight? Because of the upthrust. Upthrust is a force. We just call it upward force. So it's an upward force that is acting contrary to the gravity. When we talk about weight, we are also referring to the gravitational force that is acting on the object towards the center of the earth. So it's going to act against the weight of the object. So definitely the weight of the object will decrease. So you call that weight of the object in water or in liquid, you call it apparent weight. So if I want to do this now, if I want to illustrate this, it means apparent weight, apparent weight equals um, weight of the object, weight of the object minus upthrust. All right. I can also say upthrust equals weight of the object minus the apparent weight. Apparent weight simply means um, the weight of the object in liquid. So finally, I can express it as, if I call this, can call this weight of the object. Let's call it W1, and then the apparent weight is now W2. All right. So having the understanding of this will um, will will help a lot, because it will enable you to solve any related questions in this aspect. All right. So that's very, very important to note. Now, what do I need to say about this? Okay, so now let's look at this example that we have. A solid weighs 0.04 Newton in air and is 0.024 Newton when fully immersed in a liquid of density 800 kilogram per meter cube. So calculate the volume of the solid. Okay, I have just said that, I've just said here that apparent weight is also can also be referred to as the weight of this object in liquid. Okay, let's dive into the question now. So a solid weight 0.040 Newton in air, 0.024 Newton when fully immersed in a liquid of density 800 kilogram per meter cube. Calculate the volume of the solid. Now, solution. Solution. So we are given the weight in air and weight when fully immersed in liquid. So it means upthrust is weight in air minus weight in liquid. So we can simply say, because of space, let me split this into two. So this is simply weight in air. Weight in air is 0.040 Newton minus 0.024 Newton. So if you subtract this, this is going to give you 0.016 Newton. So this is the upthrust. It means this is the upward force that is acting on that solid, all right, as a result of being immersed in this liquid. Now, the liquid has a density of 800 kilogram per meter cube. That's the density of 800 kilogram per meter cube. Now, note, when I was explaining this, I told you that upthrust is equal to the weight of the fluid displaced by an object. Is an upward force which is equal to the weight of the fluid displaced by an object, because as soon as you immerse an object in a liquid, there will be a rising of liquid, okay, as a result of the object that is being immersed. So that rising of liquid is called a displaced liquid. All right. If the container, if the container is if the container is not high enough, the water is going to displace away. It's going to displace away. So the weight of the object that is immersed in the fluid is equal to the weight of the fluid that is displaced. From here, so from here we can simply say that upthrust is also equals to the weight of the liquid displaced. Weight of the liquid displaced. Okay? Weight of liquid displaced. Let's represent that with WD. Okay? Weight of the liquid displaced. Now, weight of the liquid displaced is WD. So to get, since we have been given the density of the liquid to be this. Okay, so the next thing is, since we know the weight of the liquid displaced, we can also determine the mass. We can also determine the mass of the liquid. And you know that mass, the weight is mg, that is mass times acceleration due to gravity. So we have been given acceleration due to gravity. So yeah, let's simply make mass the Soreto formula. So which means we have WD over G. Alright. So mass will then be the mass of the liquid displaced will then be the weight that we got here. Remember, we have said upthrust is equals to weight of the liquid displaced. So that's 0.016 divided by 10. The acceleration due to gravity constant. So that gives us 0.0016 kilogram. So, but what we want to determine is the volume of the solid. Then recall that density is equal to mass divided by volume. So you multiply density multiplied by volume is equal to mass, which means volume is equal to mass over density. So our mass, the mass of the liquid displaced, and then we have been given the density as 800. So just divide, that will be 0.0016 divided by 800. So the volume of the volume will be that's let me apply. So let me apply calculator. So that's 0.0016 divided by 800. So that gives us 2 times. So that's 2 multiplied by 10 raised to the power minus 6 meter cube. Okay. So dividing that with calculator, you have 2 multiplied by 10 raised to the power minus 6 meter cube. So remember, the same way the weight of the liquid displaced, the ultra is equal to weight of the liquid displaced. So it's the same way that the volume we just calculated now is the volume of the solid, because this the volume of the liquid displaced is the same thing as the volume of the solid. The same way the weight of the liquid displaced is the weight of the solid that is immersed. It's the same way the volume of the liquid displaced is also the volume of the solid that was immersed. So therefore, the volume of the solid, the volume of the solid equals 2 multiplied by 10 raised to the power minus 6 meter cube. All right. So you can go ahead and do this. Attempt this. It's almost similar to the example above. All right. And whatever you get as a solution, you can drop it at the comment section. So before we wrap it up, I have said that you may not be responsible for where you are today, but you are definitely going to be responsible for where you'll be tomorrow. That means God has given you the will to change your current situation. God has given you you have a choice to change where you're going to be tomorrow. So I leave you with that till we meet next time. I remain Ayubu Situnde. Bye.